Hello, today we're going to do standard deviation. Now, this is a pretty complicated topic. We do this in Foundations 11, and it always gives people some difficulties. So we're going to challenge you a little bit today, but I know you can do it. So what we're going to do to start is we're going to look at two sets of data. We have this set right here, 5, 5, 5, 5, 5, and we have this set, 1, 2, 5, 5, 5, 12. And we're going to calculate the four things we learned last time: mean, mode, median, and range. So let's do that right now. So we'll start with the one on the left, the mean. When we say the word mean, what we mean is average, right? It's what we commonly refer to as average. So how do we get that? We add them all up. So 5 plus 5 plus 5 plus 5 plus 5. And we divide by how many there are. 1, 2, 3, 4, 5. So we're going to divide by 5. All right, you add them all up. 5, 10, 15, 20, 25 divided by 5. 25 divided by 5 is 5. So that's our mean. Let's get the mean for this one too. So we add them all up. 1 plus 2 plus 5 plus 5 plus 12. And we divide by 5. If we add them up, I'll start with the big one. 12 plus 5 is 17. Plus another 5 is 22. 24, 25. Oh, we get 25 over 5 again. We again get 5. So it has the same mean. Okay, mode. What's mode? Mode is the one that's the most common. Well, in the first set we have 5, 5, 5, 5, 5. I would suggest the most common one is 5. In the second one we have 1, 2, 5, 5, 12. I would suggest that the mode again is 5 because there's two of those and only one of the other ones. Okay, median. Median is the one in the middle. So if we arrange these in order from smallest to biggest, well, they're all 5. Obviously the middle one is 5. If we arrange these in order, thankfully they're already arranged in the order from smallest to biggest. Which one's right in the middle? That's the one right in the middle. So our median for this data set is also 5. Now, I want you to take a look at this for a second. And these two data sets, they have the same mean, 5 and 5, the same mode, 5 and 5, the same median, 5 and 5. So, you know, those were our measures of central tendency, those three things, and they have the same numbers. But if you take a look at these and take a look at those, I think you'll agree the numbers are a lot different. So this takes us to the last two. I probably should have done range today because this takes us to the last two things, range and standard deviation, which really describe how these two are different. If you were to describe how they're different, what would you say? We'd probably say something like all these values are really, really close to each other. In fact, they're exactly the same. Well, all these values, they have a certain amount of spread to them. Like they're varied. They're spread out, right? All right, so we know how to do range, don't we? We just take the biggest value and subtract the smallest value. So in this case, I guess it would be 5 take away 5, which is 0. And that makes sense. There's no range here. There's exactly the same, all the values. How about this one? We go 12, that's the biggest value, take away 1, we get 11 as our range for that one. So range does a pretty nice job of explaining the difference between these two data sets. But there's something else that can also be used. It's called standard deviation. This is really common when you hear polls and stuff on the radio or the news or whatever. They'll often talk about, 62% of people agreed with Donald Trump with a standard deviation of 3%. And you might wonder what that standard deviation means. So we're going to teach you today. Standard deviation measures the spread of data. It literally measures how spread out the data is about the mean, like how far from the mean is the majority of the data. All right, so we're going to figure out the standard deviation for these two sets of data here, the two that I've highlighted in green. But we need to know how to do that first, and we need a formula, and this is one heck of a formula. You ready? Boom. All right. I've tried to actually simplify it for you a little bit. In fact, there's all these crazy symbols that are used to represent standard deviation and mean and the first value and everything, but I thought this might be a little bit easier to wrap our heads around. So, standard deviation, which is what we're trying to figure out, is equal to, you get the mean. Remember, mean is what we got up here. We already know the mean is 5. You take the mean, you subtract the first value, so in this case it would be 5, in this case it would be 1, and then you square that amount. Then you do the same thing for the second thing and square that amount. and you add those two things together. And you keep doing that. For the third value, you do mean minus third value, square that, add it on. Mean minus fourth value. Now, I don't know how many values we're dealing with. In this case, it's 5, but you could do this with 2 or 100 or whatever many values. So we have the dot, dot, dot to show you keep doing this until you get to the last value. Same thing. You take the mean, subtract the last value, square it, add it to all the rest, and then you're going to divide all of that by the number of terms. And here's the thing, once you've done all this, you're not done. There's one last step. You take the square root of whatever answer you had after you've done all that. Oh wow, what a formula. Alright, should we find the standard deviation of these two data sets up here? Yes, we should. Let's do it. So I'm going to rewrite the data sets down here first of all. Give me a second. Okay, there we go. So let's start with the one on the left here. We're going to find the standard deviation. So we're going to eventually take the square root of something, and I'm going to put a line here because we're going to have a big fraction. And let's go. The first thing we have to do is we have to find the mean. Well, we already know the mean. We figured it out up here. It's 5. So what we do is we take that mean, which is 5, and we subtract the first value. That's this one right here. So we're going to subtract that 5, and then we're going to square it. Plus, we take the mean again, which is 5. We subtract the second value, which is also 5, and we square it. Plus, we take the mean again, we subtract the third value, which is 5, and square it. Plus, we take the mean, subtract the fourth value, and square it. Plus, the mean, take away the fifth value, and square it. And then we're going to divide all this by how many terms there were. There were 1, 2, 3, 4, 5 terms. So this is what we have to do. Once we've done all that, we'll have our answer. Alright, so this one's not all that interesting because you get a whole lot of zeros in here. 5 take away 5 is 0, and then we're going to square it, and 0 squared is 0, right? Because 0 squared is 0 times 0, which is still 0. Plus, 5 take away 5 is 0, and then we square it, you get 0. Wait a minute, this happens every time. 5 take away 5 is 0, squared is 0. So this one equals 0, 5 take away 5 is 0, and then square it, you get 0. And this last one also equals 0. And then we're going to divide it by 5. So if we add all those zeros together, guess what you get? You get 0. And we're going to divide it by 5. 0 divided by anything is 0. So the last thing we have to do is take the square root of 0. What multiplies by itself to get 0? 0 multiplies by itself to get 0. This is your standard deviation. And that makes sense, right? There is no spread in the data here. All the data points are 5. The mean's also 5, so there's no spread around the mean because they're all exactly equal to the mean. Not the most interesting one. Let's take a look at this data set, which will be a little bit more interesting. So, standard deviation equals big square root sign and big fraction bar. Okay, so where do we start? We start with the mean, right? We're going to start with the mean, and the mean in this one is as well 5. They were the same mean. So we're going to go 5, take away the first data point, which is 1, and then we square it. Plus the mean, which is 5, take away the second data point, and then we square it. Plus the mean, which is 5, take away the third, squared, plus the mean, take away the fourth, squared, plus the mean, take away the fifth, which is 12, all squared, and we divide by how many terms there were. 1, 2, 3, 4, 5 again, and we're off and running. Here we go. So first we get 5 take away 1, which is 4, and we're going to have to square it. Plus 5 take away 2 is 3, and we're going to have to square it. Plus 5 take away 5 is 0, and square it. 5 take away 5 is 0 again, and then square it. Plus, we're going to the negatives, people. Put it in brackets. 5 take away 12. That actually goes to -7, and then we have to square -7. This is all divided by 5. So what's 4 squared? That means 4 times 4, which is 16. 3 squared. 3 times 3, 9. 0 squared, we did that over here. 0 times 0 is 0, and again here, 0 squared is 0. Now, right here, this is all of this number, including the negative squared. You have a -7 times another -7. Negative times negative is positive. In fact, in terms of this squaring step, make sure that there'll never be a negative amount. Because either you're squaring a positive amount like this, which stays positive, or you're squaring a negative amount like this, which will turn into a positive. So you should never get a negative in this step. Negative 7 times negative 7 equals positive 49. And we're going to divide that all by 5. And you see what I missed? In this last step, I forgot to include my square root sign. And I'll put it again here. It's a bit messy, isn't it? Okay, next, we got to add those all up. So we still have our square root sign. We still have the 5 on the bottom. 16 plus 9 is 25, plus 49 is 74. If you divide 74 divided by 5, you get 14.8, and then you take your calculator and you figure out what the square root of 14.8 is, and you'll get 3.85. So obviously the 3.85 is a bigger spread. There's more spread of data around the mean of 5, and that's obvious from the data here. Now, that took a lot of work, didn't it, to get those standard deviations? I bet you don't want to do many of those questions. Well, guess what? There are calculators to help you. So there are calculators online. You can also download apps for your phone, which, why wouldn't you? It's so awesome and cool. That can figure out all these things, mean, mode, median, range, in a second. So that's what we're going to do right now. So the first thing I'm going to do is I'm going to cheat, and I'm going to copy this first question here. I can't copy it here, so now I have copied it. And all I'm going to do is I'm going to go to a calculator online. I found this one, Calculator Net, and it works very well. I'm actually going to go down here. I know this looks more like the calculator you're used to, but if you go down here, it says provide the values separated by a comma below. So I just paste in all my values here, and there we go. There is a comma between each one of them. Notice it doesn't even matter whether they're in order from smallest to biggest. I hit calculate, and you're getting more than enough stuff here. I mean, I'll go through some of this with you. Count. Count means how many numbers did you input? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We put 9 numbers in. Sum, what do they all add up to? The mean. There you go. There's the mean, which they also call the average. But remember, mean, median, mode are all averages. But they're trying to help you out because most people do call the mean the average. They tell you that the mean is 21. So let's go back and put 21. Oh, it also tells you that the median is 16. So mean 21 right here, and median was 16. Okay, let's go find the mode and the range. The mode, all values appeared just once, right? There's no repeats there. So what's that mean about our mode? It means there is none. So we're writing none in here. Okay, largest. So the largest value is 49. The smallest value in our list is 7. There's the range, 42, right? 49 minus 7 is 42. And the only other thing we need is standard deviation. And now, they give you some extra things here. They give you geometric mean. Don't worry about that. They give you standard deviation. Beautiful, we want that. They also give you variance, sample standard deviation, and sample variance. Don't worry about all those things. But standard deviation we want. And it is 12 let's call it 12.11. How about that? And that's it. It's as simple as that. Now, why don't I just get you to do that right off the bat? Because I want you to understand these things, right? And I'm hoping this makes sense to you, what all these are referring to. So let's do it once more with this data. Now, before we do it, I just wanted to see if you could tell me something. Take a look at this data up here, and take a look at this data down here. And can you tell me whether the standard deviation we find for this is going to be more than 12.11 or less than 12.11? What would be your guess? I'll give you a hint. If we were to calculate the range, this is already in order from smallest to biggest. This one's not, which makes it a little bit hard to compare. I should have put this in order. But this one is in order from smallest to biggest. And you can see the smallest is 17, the biggest is 26. If we did 26 minus 17, you would get a range of 9. So what do you think? The range was 42 up here and 9 down there. Would you predict that the standard deviation is going to be more or less there? It's probably going to be less. So let's see. So again, I'm cheating. I don't want to type them all in. So I'm just going to copy this. I'm going to replace all these with my new numbers. There they are. I'm going to hit calculate, and I've got everything I need right here. There's 12 numbers that went in there. They added up to 252. Mean and median are both 21. And so's mode is 21 too, but it has two modes. So 17 is also a mode. So we got 21, 21, and 17, 21. 21 for mean, 21 for median, and 17 and 21 for mode. That makes sense for mode because we have 3 17s and we also have 3 21s, and that's the most. And the only other thing we need is standard deviation. And remember, don't take sample standard deviation. It's literally just the standard deviation. And we'll do 2 decimal points again. So we got 2.94. And 2.94 is a lot less than 12.11. Why is that? Because this data is not spread out as much. The mean is 21, and all the data, these ones are 4 away from the mean, and this is 5 away from the mean. In this one, the mean was 21 as well, the same mean, but we went all the way down to 11, which is 10 less, and all the way up to 49, which is what, 28 more? So that's a lot more spread there. Okay, everyone, that's standard deviation. Kind of a confusing topic, but important. You'll definitely hear about standard deviation a lot in the real world. Bye.